If we were to remove the constraints of distance and perspective, the most fascinating celestial object that captures my attention is one that holds a unique place in our sky, Betelgeuse. This colossal red supergiant star is one of the most intriguing stars known to astronomers. If Betelgeuse were positioned where our Sun is, its immense size would extend beyond the orbit of Jupiter. This massive and highly unstable star is nearing the final stages of its existence, teetering on the edge of a cataclysmic explosion. However, as with many cosmic phenomena, the process is far more complex than it seems. When stars of such magnitude reach their end, their explosive demise can reshape not only what we observe but also what remains hidden from our view. Although Betelgeuse is not the only red supergiant in the universe, it is one of the most well-studied and serves as an archetype for this class of stars. Its sheer size and luminous presence make it an excellent subject for astronomers who seek to understand the nature of stellar evolution. Notably, British physicist Brian Cox, alongside many other researchers, has expressed the belief that Betelgeuse is approaching its inevitable supernova phase. Growing interest in the star has intensified, particularly as the James Webb Space Telescope has captured stunning images revealing new details about its structure and behavior. This has led to one pressing question. When exactly will Betelgeuse erupt into a supernova, and what consequences might such an event have for Earth? Betelgeuse is a radiant star in the famous Orion constellation, known for its striking brightness, which even ancient civilizations observed and documented. Positioned on the eastern shoulder of Orion, it ranks as the second-largest star in the constellation. The name Betelgeuse is derived from its location, indicating its role as a shoulder star in Orion's celestial figure. Despite the many brilliant stars visible in the night sky, Betelgeuse stands out due to its unusual red hue, which has long intrigued astronomers. This distinctive color is a key indicator of the star's stage in its life cycle, signaling potential instability and eventual collapse. Humanity has been fascinated with Betelgeuse for centuries. The ancient Greek astronomer Timocharis first recorded observations of its reddish-orange glow, recognizing that a star's color could provide insight into its properties. Since then, astronomers have continued studying Betelgeuse with increasing precision, uncovering new aspects of its nature. One particularly notable characteristic of Betelgeuse is its classification as a variable star, meaning its brightness fluctuates over time. In 2019, scientists observed an unprecedented dimming of the star, causing its luminosity to drop significantly. Although it never completely vanished from view, Betelgeuse's brightness decreased by an astonishing 1.6 magnitude. This event sparked widespread investigation into what might be causing such erratic behavior in one of the sky's most recognizable stars. Experts now believe that Betelgeuse could explode as a supernova at any moment. Brian Cox, a renowned physicist and public science communicator, has emphasized the unpredictable nature of this impending event. As a professor of particle physics at the University of Manchester and a prominent science educator, Cox's perspective carries significant weight. He has described Betelgeuse as a ticking time bomb, one that could detonate with little warning. Supporting this claim, data from the James Webb Space Telescope has provided compelling evidence of unusual activity surrounding the star. Yet, many questions remain. Why does Betelgeuse exhibit such erratic fluctuations in brightness? Could these irregularities be the harbingers of an imminent explosion? Betelgeuse is unquestionably a prime candidate for a supernova. Its mass is nearly twice that of the Sun, which is a crucial factor in determining whether a star will end its life in a dramatic explosion. Typically, stars that are several times more massive than our Sun undergo supernovae when they reach the end of their nuclear fuel supply. However, despite its classification, the precise timeline of Betelgeuse's fate remains uncertain. Scientists have employed a variety of advanced tools, including the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, to probe the mysteries surrounding this star. Their findings, though enlightening, continue to raise new questions. Astronomers have detected peculiar light waves emanating from Betelgeuse, further fueling intrigue. Moreover, the star's dimming behavior appears to be changing over time. Historically, Betelgeuse has experienced periodic dips in brightness, but these fluctuations have become more pronounced and frequent. In February 2021, astronomers recorded another notable dimming event, observing that Betelgeuse had reached a brightness level of approximately 1.61 magnitude. This occurred shortly after the Great Dimming Event of 2019 to 2020, further intensifying speculation about its impending fate. Some researchers now believe Betelgeuse's explosion could occur within the next 100,000 years, a mere blink in cosmic time. However, when the star brightened again following its unexpected dimming, scientists were left even more perplexed. Harvard astrophysicist Andrea Dupree noted that Betelgeuse became 150% brighter than usual, briefly ranking as the seventh brightest star in the sky. This dramatic variability has led scientists to develop multiple theories regarding the nature of Betelgeuse's recent behavior. Some suggest that massive ejections of stellar material, similar to coronal mass ejections from the Sun but on a vastly larger scale, may be responsible for its fluctuations. The James Webb Space Telescope has detected vast dust clouds surrounding Betelgeuse, which could explain some of its unpredictable dimming events. Unlike typical stars, Betelgeuse emits a distinct red glow, a signature of its red supergiant phase. This coloration results from its relatively low surface temperature of approximately 3,500 Kelvin, significantly cooler than the Sun's outer layers, which measure around 5,500 Kelvin. Despite its cooling temperature, Betelgeuse is rapidly approaching its final collapse. Brian Cox and other astronomers have questioned whether its erratic behavior truly signals an imminent supernova. While many indicators suggest that Betelgeuse is nearing the end of its life, the precise moment of its explosion remains unknown. Scientists continue to monitor the star closely, utilizing cutting-edge telescopes and instruments to capture real-time data. The James Webb Space Telescope has provided invaluable insights into Betelgeuse's recent dimming events, revealing that the star expelled an enormous amount of material, roughly 400 billion times more than a standard solar mass ejection. When Betelgeuse ultimately explodes, it will be one of the most spectacular astronomical events witnessed in modern times. Such an explosion will release an immense amount of energy, temporarily making Betelgeuse as bright as the full moon. However, despite its sheer power, Betelgeuse's supernova will not pose any threat to Earth due to its considerable distance of over 600 light-years. Instead, this cosmic event will provide scientists with an unprecedented opportunity to study the mechanics of stellar death and the effects of supernovae on surrounding space. Betelgeuse's impending explosion serves as a powerful reminder of the dynamic and ever-changing nature of the universe. Massive stars like Betelgeuse play a crucial role in the life cycle of galaxies by dispersing heavy elements necessary for the formation of new stars, planets,